Artificial intelligence is making more and more critical decisions that affect our lives, from our finances all the way to our health. But here's the thing. A lot of the time, these decisions come from a total black box that we just can't understand. So let's dive into this quest for answers, into the world of explainable AI. So here's our game plan. First, we'll get right to the heart of this black box problem. Then we'll dig into why we even need answers in the first place, and for who. From there, we'll peek under the hood and see how these explanations actually work, check out some really cool real-world examples, and finally, we'll talk about what it's going to take to build AI that we can actually trust. Okay, so let's start with the core issue, right? We're using these incredibly powerful machine learning models, but all that power comes at a price. Often they're so complex that even the people who built them can't fully trace their logic. And that's the black box problem. To make this super real, just imagine this for a second. You apply for a loan you really need, or maybe for your absolute dream job. An AI makes the call, and you're rejected. I mean, the stakes just couldn't be higher. And that's the kicker. You get zero reason, no feedback, no explanation, just a no. And this isn't just frustrating, right? It feels deeply unfair. It leaves you totally powerless, with no way to understand what happened, let alone challenge it or figure out how to do better next time. So what makes a black box so tough to crack is that it isn't just complicated. Its way of thinking can be totally alien to us. Even if we could see all the wires and circuits inside, we wouldn't necessarily get why it made a choice. And this is the fundamental challenge that explainable AI, or XAI as you'll hear it called, is trying to solve. And this need for clarity, it's not just about one person's frustration. It actually builds into a much, much bigger picture. The demand for answers is coming from all over the place. There's a whole ecosystem of people and principles all pushing for transparency. I mean, just look at how many different people need an explanation. It's not just the person who got denied the loan. It's the doctor who has to trust an AI's diagnosis, the government regulator making sure a bank's algorithm isn't biased, and heck, it's the investigator trying to figure out why a self-driving car made a fatal mistake. Literally everyone has a stake in understanding these decisions. And this is exactly where we connect the needs of all those people to a bigger ethical framework. Principles like fairness, accountability, preventing harm, these aren't just nice ideas. They're the absolute bedrock of what we call trustworthy AI. An explanation is the bridge. It's the thing that connects the AI's technical nuts and bolts to these crucial human values. Because of this, governments and big organizations are starting to create formal guidelines. What you're looking at here is a framework from the EU's expert group on AI, which breaks down trustworthiness into these core requirements. This isn't just a friendly suggestion. This is the beginning of a global standard for how to build AI responsibly. And in some parts of the world, it's already the law. The European Union's GDPR, for instance, literally gives people the right to obtain an explanation for automated decisions that have a major impact on their lives. This completely changes the game. It shifts explainability from a nice-to-have feature to a straight-up legal necessity. Okay, so we've established that we absolutely need explanations. But how? How do we actually get them? Let's dive into some of the methods that data scientists have come up with to shine a little light inside that black box. All right, the first big thing to understand is the difference between local and global explanations. A local explanation is super specific. It answers the question, why did this happen to me? A global explanation, on the other hand, zooms way out. It tries to describe the model's overall logic, answering, how does this system work in general? You really need both, but for totally different reasons. Now, one of the most popular techniques out there for these local explanations is called SHAP. It's a really clever method that's actually borrowed from game theory. Basically, it treats every piece of your data, your income, your credit score, your age, as a player in a game. Then it calculates exactly how much each player contributed to the final score, or in this case, the decision. Now, this might look a little complicated at first, but it's telling a really simple story. The best way to think about it is like a detective laying out all the clues. That baseline in the middle is our starting point, the average prediction. Every red bar is a clue pushing the decision one way, say towards approved. Every blue bar is a clue pushing it the other way, towards denied. This chart shows us clear as day which clues were the most important in solving the case of your loan application. And SHAP is just one piece of this puzzle that is evolving incredibly fast. I mean, look at this timeline. It shows a complete explosion of new methods in just a handful of years, each one tackling the problem from a slightly different angle. It just goes to show you how intense and how important the research in this area has become. And look, this is not just stuff for academic papers. Let's talk about how XAI is already making a huge impact in really high-stakes fields like finance and healthcare right now. So first, just think about the sheer power we're trying to explain here. In healthcare, some AI systems can analyze medical scans with up to 98% accuracy. That's insane. In some cases, that's better than human experts. But for a doctor to actually trust that diagnosis and act on it, they have to know why the AI saw what it saw. XAI is that crucial link. And over in finance, it's the same story. Major players, JP Morgan Chase, Goldman Sachs, they are actively using these methods like SHAP and Lime. And they're not doing it just to be on the cutting edge. They're doing it to make sure their models are fair, to build trust with their customers, and to comply with all those regulations we just talked about. And the results? They are concrete and totally measurable. By using XAI to understand and fine-tune their models, some banks have seen loan approval rates jump up and customer satisfaction improve. In healthcare, it's helped improve treatment outcomes and has even streamlined paperwork, giving doctors more time with their patients. These are real, tangible wins. All of this amazing progress leads us to the biggest question of all: how do we build on this? So let's wrap up by looking at some of the best practices for creating a future where our AI is fundamentally trustworthy. For years, the world of AI has faced this fundamental trade-off. The most powerful, most accurate models were always the least understandable, and the models that were easy to understand, well, they just weren't very powerful. The entire goal of modern XAI is to finally break that compromise, to find that sweet spot and get the best of both worlds. So, here are 4 key practices. First, design for this stuff right from the start. Second, document everything. You need that audit trail. Third, and this is huge, tailor the explanation to your audience. A developer needs way different information than a customer does. And finally, you have to actually test your explanations. The goal isn't just to make one, it's to make one that's genuinely helpful and useful to a real person. And that leaves us with this final thought to chew on. As these AI systems get even smarter, more complex, more autonomous, will the kinds of explanations we have today even be enough? Or is building true, lasting trust in our intelligent machines going to require something more? That's really the central question we'll all need to answer as we continue to build this AI-powered future.